right, Kurt Steinke. We want to talk about climate resiliency a little bit here today. Focused mostly on potato, but in general. And I think one of the themes Dave was alluding to is what can we do to make a more durable potato ecosystem, right? How can we get through those wet periods, those dry periods, etc.? Because the problem we really run into is what? All this climate variability that we refer to creates what? Starts with a U, uncertainty, right? We just don't know, right? We don't know if it's going to be wet, we don't know if it's going to be dry, we don't know whether it's going to be normal, whatever normal may be. So when you look back over about the last 10, 12, 13 years, anybody have any idea on how normal our springs have been? And this plays out across most of the state, actually, believe it or not. When you look at April, May, and June, about 50% of the time we're normal, about 25% of the time we're too wet, and 25% of the time we're too dry. All right, so good luck to you managing whatever crop you're managing, right? Protect it for drought, protect it for 14 inches of rain in a month, and protect it for normal, right? So that's where that uncertainty really comes in. And that's what we kind of want to talk about here today is how can we create that more resilient ecosystem? And we talk about, steps growers take to address some of this variability and uncertainty. And some people think, well, I haven't done anything. Yeah, everything's the same today as it was 10 years ago. Well, when do you plant? Everyone plant at the same time they did back in the year 2000 or 1995 or 1990? Absolutely not. We're planting a lot earlier. There you go. There's one thing. What are you planting into? You're stating on cooler soil temperatures in many cases, right? When you plant maybe the third week in March as opposed to maybe the third week in April, that's a different environment. Think about the autumn, all right? When we talk about climate variability and uncertainty, we always think about spring and maybe to some extent summer. Think about the autumn. What has really changed about our autumns? We're staying warmer for a longer period of time. All right, so when I look back up, towards the thumb of Michigan, we used to drop below 50 degrees Fahrenheit about October 5th to the 10th, all right, somewhere in that range. And why is that 50 degree number magic? Well, above that, we tend to nitrify some nitrogen. Microbes are working along. We're mineralizing nutrients. Below that, things start to cool off and slow down. Well, nowadays, when you look at when we permanently drop below 50 degrees in that same area, it's about November 5th to the 10th, an entire month later, all right, which really has an impact on our root and tuber crops. When you start thinking about potatoes, sugar beets, etc. That old mindset that come Labor Day, management could stop no longer applies. All right, we still have disease conditions above ground. We still have disease conditions below ground. So that is one or another aspect of this uncertainty with climate variability. So that's something we want to address. What can we do about it, right? One thing we've really looked at over the last probably decade or so is early season nutrient management, all right? And that boils down to what I've coined the 5 words, start right to finish well. All right, you got to get that plant off to a good start early in the season. Why? We don't know what June's going to look like, right? Look back at the last 10 years of Junes. You can find probably, I'm going to say a couple years ago, we had areas of the state that had 8 to 14 inches of rain in June. You can look back at this last June for the first 24 days. We got a big goose egg. We got nothing in many parts of the state. And so we just don't know, all right? You can look back at the springs that we've had, even this spring of this year. Down in the southern part of the state, between I think April 23rd or 24th and June 23rd, we got about 0.45 inches of rain. Is that normal? Absolutely not. All right, so we have to deal with it. And that's where some of that early season nutrient management can really come into play. All right, get that plant off to a good start to capitalize on those mid-season environmental conditions. Now, when should we use starter? How much should we use? We've looked at that over the last number of years. We've revised the Tri-State Soil Fertility Recommendations this last year. That was about an 8 or 9 year project between Michigan, Indiana, and Ohio. So we have those out. We're going to tweak the Michigan recommendations going forward here soon also. One thing to think about is think about the variation in geography. Just think about potatoes. Where potatoes are planted in the state of Michigan. From that first tuber that goes in the ground come springtime in the southern part of the state till that last one goes in the ground maybe in the UP. All right, you got about 500 miles. All right, you got about a 500-mile difference in geography. soil temperatures are going to vary quite drastically within those 500 miles. So you look at when some of the first crop went in the ground this year, soil temperatures were probably about 35 to 38 degrees Fahrenheit. All right, you can go out to the northerly parts of the state, they probably still had snow. All right, now the interesting thing is, you look at when we cross that threshold, that 50 degree Fahrenheit threshold permanently. I looked the other day, when you look at an area like southwest Michigan and the UP, all right, when did they permanently raise above 50 degrees Fahrenheit? It was almost within a single day. All right, so it warms up uniformly across the state, right, at a certain time, but that those planting conditions will vary between north and south to north. So that's something to think about. One thing we've looked at over the last several years is P2O5, or phosphorus response in potato production. All right, one thing we've really noticed in these high soil test phosphorus soils, we still see a response to about 40 pounds of P2O5. All right, they still respond because of the nature of that crop. You don't have, when that tuber goes in, we don't have many of those seminal roots formed, and so we tend to see a response. Beyond that, it's going to vary on soil test phosphorus level. So that's one change that'll be coming with regards to the potato recommendations. With the revised tri-state guidelines, focusing predominantly on P and K recommendations, we're probably all used to that build up, maintain, and drawdown approach. That drawdown approach is now gone. All right, when you're above that maintenance level, the recommendation will now go to 0. So that may impact a little bit of the P and K recommendations a little bit also. When does starter pay off? All right, again, soil temperature. Typically, we have a moderate to high chance of seeing a response to the starter if you plant when soil temperatures are about 55 degrees and under. All right, when you get above that threshold, the probability of seeing a response to a higher rate of starter tends to decrease quite drastically. So, nitrogen. The question always becomes nitrogen, where did it go, and can that plant find it? All right, so when you look at what are the odds, every time a grower makes a big or a bulk N application, what happens? You get that 4-inch rain, right? I don't care when you do it, I don't care what crop you're going, it just, that's what tends to happen. Get that 3 to 5 inch rain. How do we deal with it, and what can we do about it? Well, we just put a study out looking at where does the uncertainty with N come from? Does anybody have any idea what percent of uncertainty with your nitrogen comes from the weather? Think it's 25%, 50, 75, higher, lower? Any ideas? Your nitrogen.
What aspect of the uncertainty?
Whether it's there or not. What affects it? What percent is affected by the weather?
70%.
Good guess. It's about 77 to 89% of our uncertainty with nitrogen is controlled by the weather. All right, that's a huge component. You start talking about crop management factors, they play a much, much, much minor role as compared to the weather. So then it becomes, what can we do about the weather? And the age-old answer is nothing, right? Wait a day and it'll change. But there are things we can look at to maybe make better use of perhaps some of those N applications. We know about some of the slow release N products out there. We know about the inhibitor products, urease inhibitor products, nitrification inhibitor products. Those are all potential tools. Some work better than others, and some work better in certain areas than others. So that is something to think about going forward. The other thing to think about is, what did you apply? This is a question that I always ask students is, first off, where does fertilizer come from? All right, and the response I get is usually, it's written on your boots or it's written on the ceiling tile when you're sitting in the classroom, because nobody has any idea where fertilizer comes from, because the answer is it comes from the co-op, right? Absolutely not. We know that's not the truth, all right? But not only where does it come from, what is it made of? Have an idea of what you're putting down. There's a huge difference if you start talking about urea, you start talking about UAN, you start talking about ammonium sulfate. For those of you that still use some anhydrous, there's huge differences in the amount of nitrate in those products. All right, and the amount of nitrate in those products, if you get a big rainfall soon after, that's going to help determine how much N either is or is not remaining after that large rainfall event. So that's something to consider going forward. The other thing, how far does it move? Right, a good rule of thumb, when you start talking about each inch of infiltrated water, all right, on fine textured soils, and it'll move about 4 to 6 inches. Right, on our coarse textured, you're looking at about 6 to 12 inches. Now, that's not each inch of rainfall. If you get a 4-inch rainfall, you typically don't get 4 inches of infiltration. That's for each inch of infiltrated water. So that can give you some idea on maybe where it is and whether that plant can find it again. The other thing to think about is conditions after these wet time and point scenarios, right? So if you get 4 inches of rain, it begins to dry out. What happens? Water starts getting wicked upwards in that soil profile. So you can actually get some of that end movement upwards. How much? Yeah, about 1/3 of an inch a day. Right, so oftentimes if we get in this wet spell, then we get this dry stretch, you can kind of see the reverse. You get a little bit of that upward movement in that soil profile for some of that nitrogen. With P and K, keep in mind, especially for those of you that may irrigate it on, fertigate it on, etc., you need those surface roots to absorb those irrigated or irrigation applied P and K sources that are out there. So, a couple things as we wrap up. Long term, remember your soil test nutrient concentrations. Try to build and maintain those over the long term. That's still proven probably the most cost-effective approach. Gets a little bit trickier, a little bit dicier with owned acres versus leased acres. Become a bit of an issue. Don't forget pH. That is still probably the #1 factor when you see a problem area in a field and or you see a nutrient problem in the field. Okay, soil pH still can dictate a lot of what we do or do not see in the field. And remember, dry matter. Dry matter can really drive nutrient uptake. All right, and so the more dry matter you get, the more nutrients you can uptake. But at the end of the day, remember that not only holding nutrients in the soil will impact what is around, but those those factors that impact plant growth and development will also impact how much of a nutrient is or is not around at the end of the day. So, last point is nutrient management and water management go hand in hand. Right? Nutrients don't move by themselves, right? Some of us think they do. They move in the ground magically. No, they need water. You need water to get that fertilizer to the plant, and you need water to get fertilizer moving away from the plant. All right, so water management can play as big of a role in nutrient management moving forward with regards to durability. The question was, can you afford to go to a 1 acre grid from a lime standpoint? And my response would be, how big's your checkbook, Lyndon?
Wife only lets me pay for things that make money, so.
I know how that goes. You know, the more precise you are with your soil sampling, the bigger the payoff's going to be, right? So I would say, look at that soil variability across a specific field. Now, when you talk about soil variability, oftentimes we think about horizontal variability, right? Whether it's from a drone picture, whether it's from an aerial image, but also think about that vertical variability across that field, right? Oftentimes you get an area like we're here in today, you get that coarse textured sand about 15 inches on the surface, and what's immediately underneath it? A layer of clay that can hold a lot of sulfur, for instance, that corn plant can capture, that potato plant may not. So, it's going to change on a site-specific basis, all right? But at the end of the day, the more precise you are with your soil sampling and taking it at the correct depth, the better that nutrient application is going to pay off in the long run, and that lime application. Good question. I got a question. Oh, go.
Back up on that, Vicky. Are you gonna drop nitrogen 12 inches of soil, and then you're gonna wick it back up, how far back up, and how much nitrogen can you gain from that?
Yep. So if it the question was, if you start to lose N, can it be found? And with our more deeply rooted crops, corn, for instance, yes, you can absolutely find that N that moves lower in the soil profile. With potato, it gets a little more tricky, right? When you get outside about that top foot of soil. So, the old rule of thumb that pretty much still applies is for each inch of infiltrated water, you can move that nitrate about 4 to 6 inches. All right, and on coarse textured soils, it'll move about 6 to 12 inches. Now the key is it going to stay wet? Well, first off, do you have roots? All right, so do you have a sufficient rooting system? And then you get that wet spell, and then do you get this dry spell? If you get this dry spell, oftentimes you can get that nitrate to begin to wick up about 1/3 of an inch a day, okay, through that soil profile. If you don't get that dry spell and it stays moist, it's probably not going to start wicking up. So there's a big difference between wet, dry, dry, wet, 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 and dry, dry, right? And you can see out of those 4 scenarios, I think we've had each of them over about the last 6 years. All right, so it's all about after that big rainfall event, do you get that drying out of the soil? Then you can get that upward wicking movement of that nitrate through the soil. Good question.
So if I've got my crop growing and we just got 3 inches of rain, do I not even hesitate about going back in with some N?
The first question you want to ask is, of that 3 inches, was it 3 inches in a half hour?
Yeah.
Was it 3 inches over 3 days? Big difference, because it's all about how much water actually infiltrates. The other thing is, can you have some idea of how much N was present in that soil? All right. When you look at soil conditions this spring, you know, we didn't have N loss conditions from a under the surface perspective most of the spring across a good chunk of the state because it was so dry, right? So do you have any data that show how much N was there before the rainfall? And if not, then you start looking at probably some crop records, soil records, etc. on should you apply, should you not apply, how much was applied previously, things like that, and that rotation. The big thing is you got to have the roots, right? So if you get that 3 inch rain, you know, and you're very early in the season, you probably don't have the roots to tap in to any nitrate. Later in the season, it's a little bit less of an issue.